Hello and welcome. I'm running a little bit behind today, so it's right now 44 minutes until the time I usually post my videos at. And I don't have anything ready. So I thought to myself, what of my large backlog am I reasonably confident I can get done in half an hour? And I decided to go with this one. It's called FractAIslands. This was the MEWC Brazil AI challenge case that, who was it? Eric Ashton, Lorenzo Foti, and Thomas Marcelo and I think, all competed on. Um, it was not the best AI demo because it completely crushed the AI. I bailed out of solving it with AI pretty quickly and got most of the way through with a manual solve. Um, but that live stream was kind of cutting around between us, so I figured I would do a new video on a walkthrough. So let's start my timer and let's explain. So we've got this fractal island setup. Um, so the terminology is quite important. So terrain is kind of this cell, which are in 10 different types according to the color. The map has latitude and longitude. Then there's zones and subzones. So each subzone is a block of 12 of these cells looking like this, and then each zone is a collection of multiple subzones. So let's take a look. Here's the terrain, which includes the sea. These lines mark out the zones, but also over here we've got for each zone, these are the subzones that make it up, and these are the locations of all the subzones. And I randomly spotted it on the day, but I remember now that there's a repeat here, 191. That should be 192, and then let's just name both of these. So we'll call this, I guess, Z map for zone map, and we'll call this T map for terrain map. I'm very imaginative with names. Okay, and then let's just quickly do equals sort. Yeah, let's do unique. No, let's not do unique. To call ZMap by 3, and that should be, well, let's just say equals sequence sequence 196, and we'll wrap that in an and. Okay, so now we're good. Fine. So now I need to color this. So I'm going to take these, put them in here, and then I'm going to use my robot command, right color from legend, on T map. Right color from legend. Shazam. Okay, so now what's next? Oh yeah. So let's figure out, I think for each zone I want to figure out what is there. So I can start with equals map RC. Oh, I haven't imported my lambdas. Definitely going to want my lambdas for this one. So try again, equals map RC of ZMap. And that's going to give me for each subzone, it's going to give me the number and the address where the number is, and then the row column number for that. So what I need to do is then turn that into the full list of locations. So I'm just going to unmerge that. So I've got basically a cell here. So what I want is row column of this minus row column of this is going to give me the offsets from each of these. So in other words, to get from here to up there, I need to go minus 1,000,000 in my counting system. To get down here, I need to go plus 1,000,000. To get down here, I need to go plus 2,000,002. Over here, I need to go plus 2, and so on. So I'm going to take those. I'm going to delete the corners because those are not part of the thing. And then I'm going to say to row of this 3. And actually, let's get rid of the 0 as well because I've already got the location here. So then let's go take from this last column plus this. And so now I've got, these are all the locations that are within each zone. So that's good. Yeah, I'll leave this here, but wait, let's just hard code it and then move it up here. And then the rest of this I can just clean up. Okay, so that's the subzone. I'll just call it SC num. Then the zone. There's a mapping up here, and oh, these are actually quite generously given as 3-digit numbers. So we can just do xlookup text of this 000 in case with a long setup time, I will say. Glad there are not 5-minute eliminations on this. Probably go and answer some levels now, but I don't want to. I want to get it all set up nicely. And we'll do regex match for it contains. It looks like it is erroring out. Why? Yeah, because of bloody merged cells. There we go. Oh, no, what? Are some of these not in zones? That, Oh, yes, okay. Huh? Whereas zone 1 is here. Okay, I guess only these are zones. All right, fine. Someone just say if not found blank. So let's just see. Got a total of 73. Oops. Just quickly compare that against this. I want columns of text split of this by that. Adds up to 73. Okay, cool. So then I want to call this dn. This I'll call sub zn. And I'll call this RCs. Okay, now I think we're ready to start doing some stuff. So level 1. For level 1, you must return how many subzones make up the specified zone. Okay, so I do countifs. Zn is this. Kind of wish that they... Okay, good. Level 2, you must identify the name of the terrain classification at the given coordinates. Okay, so this is latitude 60, okay? But latitude meaning row, okay? So then I think this is going to be, we'll do regex extract from here, /d plus 1, and then we'll multiply that by hstack 1,000,000 for the row and 1, and then sum. Right, there we go. What format is this trying to be? Date. Okay, go away. Then we'll say 2 ref of that on tmap. And that gives deep C. Okay. So do I have these the wrong way around maybe? M. That also gives deep C. Okay. So then we need to take a closer look. Ah, okay. So these are not 0-based. Well, I would like them to be 0-based. So I'm going to take this and put it over here. And take this and put it down here. And then just delete everything so that this map is where it should be. And now that's Sparse Grove. Yes, good. Then I suppose I'm going to need to do the same thing here. And here. So that everything lines up. Yes, good. Okay. So then put that in there, and we move on. Incidentally, I don't have the version of this file that has answers, so you'll never know if I got this right or not. I got it right on the day, so hopefully I'm getting it right now. Anyway, for level 3, you'll receive a pair of coordinates that are opposite corners of a rectangular area. You must identify how many terrains of a given terrain exist within the area. Okay, so I'm going to regex extract this /d plus 1. It's going to give me 4 things. Then I'm going to wrap rows of that by 2. That gives me the 5, 6, and the 7, 9. That's good. Then I'm going to multiply that by hstack, my 1 million and m. Then a by row sum. So 5, 6 to 7, 9. 5, 6 to 7, 9. So it should be almost all deep C and just one other thing, right? Oh, sorry, yeah, it's 12. I was thinking 15. Okay, good. Then I want to address that, and then I want to join that into a single reference with a without a colon, sorry. And then I want to ref that on tmap. And then I think if I've done this right, I can make that a reference, so I can say countifs, where that is this. Have I done that right? I have. Love it, love it. I don't think I could have done that as cleanly at the time of the case. Anyway, level 4. Instead of a rectangular area, we'll work with the area of the subzones. You must identify how many trains of the given train exist within that subzone area. Okay, so we're going to xlookup this times 1 in subzone, returning from RCs. That's all the locations. Then we're going to ref of that on tmap, and we get a bunch of fine dunes and a few coarse dunes, and the question is about fine dunes, so we're going to say that equals this. Then we're going to say sum of n of that. Hooray. All right, level 5. For level 5, must return all neighboring subzones of the specified subzone. The answer must be in ascending numerical order separated by commas. Okay, so here it's going to be helpful to have neighbors. And to do that, I need to figure out, so let's see, this is incidentally how I found the 192 bug, because I was looking, I think I looked at 181 or 182 and grabbed the neighbors of it. So 182 has neighbors that are 170, 171, 181, 183, 192, and 193. So on an xlookup, each of these in subzone, returning from the first column of RCs. That's the locations of each of those. So then the offsets of each neighbor are these. So I guess let's do 2 row of that and hard code it. And let's plop that up here. I'll put it here. And then we can get rid of that. So then we're going to say xlookup your location. Yeah, let's do it dynamically. So say take that last column plus the where we go, plus the neighbor offsets. Xlookup that in these locations, returning from the same thing, b62 hash, but the first column. And we get some NAs, and we get some neighbors, which makes sense. So 1 has neighbors of 2, 7, and 8. 2, 7, and 8, yes, good. Then we're going to say if not found blank. Then we're going to text that as 0, 0, 0. And then we're going to say by row of that. We're going to say lambda row. We are going to join with a comma space, and we're going to sort row by col. And I think that's, yeah, those seem to be in order. Actually, I think just the way I did it would get them in order without sorting, but anyway, it's fine. Although I do like to be neat, so that means I could just replace all of that with array to text, couldn't No, that won't ignore the empty. It's fine. Okay, so then let's XLOOKUP. Yeah. This times 1 in subzn, returning from, I haven't named that, NBRs will do fine. And we'll come over here and give it that name, NBRs. So we got 17, 18, 28, 30, 39, 40. Good. Oops, what did I just do? Okay, so paste that in there, and some of them, yes, here are some that have fewer. So let's look at zone 27 quickly. Here it is, 27 has neighbors 16, 28, and 38. Yeah, cool. Okay, level 6. You must return the name and the quantity of the dominant terrain, the one that appears most often in the neighboring subzone. The neighbor should be the one in the southwest direction. Ah, right, yes, I probably did want to have the neighbors split out also, didn't I? All right, fine. So let's take this, just this piece, cut it, and put it here. Okay. So then, sorry, the one to the, so the one that goes from 29 to 39. So let's just look at 29 here. The one that goes to 39 is this one. So this is the column I'm interested in. So fine. So let's look up this times 1 in subzn, returning from neighbor in that direction. Then we'll XLOOKUP that in subzn, returning from our C's. Then we'll 2ref those on tmap, and then we'll say, what? Oh, the name and quantity of the dominant terrain. Okay, fine. So we'll say most of that. Oh, I remember this. That this was not right as far as I remember. Sparse growth. So let's look at zone 29. Zone 29. So go to this edge and then go in by 2. So here and then, no, I'm going to need more help than that. So the first there. No, sorry. Yes, so this one is 28. 2, 3, 4. So then this one is 29. And down to there, which means that this one here is, yeah. I remember that the example did not match on this one, so I think the answer is sparse grove. But the question is, let MO be that. We're going to say if index MO row 2 column 2 is strictly less than index MO row 1 column 2, then we're going to say join take MO first row. Sorry, always forget where the argument goes in join. Join that with a comma space. Otherwise, I'm going to say tie, because I do like to check for ties. Ooh, ref error. What? Right. Oh, maybe it doesn't have one. It's 62. 62. No, 62 has a neighbor. Okay, what's going wrong here? So yes, we had 73. We looked that up. We return neighbors. We have neighbors. We get a bunch of stuff. Looks good. Take the most of that. Ah, right. There isn't any row 2. Okay, fine. So we'll say if error 0. Cool. Right, level 7, you need to move between subzones. Each move lets you go to one neighboring subzone. You'll receive a starting subzone and a sequence of moves. You can move from a land subzone to an aquatic one and vice versa. Count every terrain from all the subzones along the route. Each subzone should be counted only once. If you come back to a subzone you've already visited, simply disregard it. After performing all the moves, return the name of the terrain that appeared the fewest times and how many times it appeared along the route. Ignore terrains with 0 occurrences. Okay, so first thing I want to do is unique of letters of this. And then we need to bring those over here and match them up. So the one that goes to the right is +4, the one that goes to the left is the -4, the one that goes down and to the left is that one, the one that goes down to the right is that one, the one that goes up and to the right is this one, and the one that goes up and to the left is this one. Okay. So, I'm going to call this NBR pick. So then I think I want to reduce 1 times this through letters of this, lambda A, V, TLOOKUP in NBR pick. My row value is going to be my A, and my column value is going to be V. Sorry, I don't want reduce, I want scan. Do we include the starting subzone? Well, I guess we'll soon find out. I guess, well, let's just leave it for now. So then I take unique of those. Then I take choose rows of, no, you know what, I need to practice using pick for this. So we'll say pick from RCs, where the row slice is that, and the row header is subzone. That's that. Then I want 2ref of that on tmap. Then I want most of that. And then the question is, that gives me 192, 59, 55, 22. Okay, so it looks like we're not including the starting one. All right, fine. So 59, 55, 22, 22, 19, 6, 6, 3. 22, 29, yeah, okay, fine. Looks good. So then we will join with a comma space, take from the last row. Okay, bonuses. How many subzones are there on the map? Disregard the aquatic subzones. So I guess that's just the 73 that are part of zones, right? So we could say count ifs zone is not blank. Does that work? Yes, no, yes, no. That's not right. Count if zone is question mark star would work there, 73. How many sandy terrains are there on the map? We can say count ifs tmap, oops, not tmp, tmap. Does it say sandy? Or no, this is sandy is a category, right? So we'll say sum minus XLOOKUP tmap in, should have done VLOOKUP, never mind, lock to 0 equals sandy. No, that's not cool. That's not cool. What are you talking about? Give me this. Give me. Give me. No. Okay, just give me the VLOOKUP itself. Yeah, and there's sandy. So what am I missing? Sandy, I probably put a bracket in the wrong place. No. Oh, is it spelling? There's a space after sandy. What kind of a monster would do that? Okay. Yeah, now I see some trues. Fine. Okay, which subzones have the fewest neighboring subzones? The answer should be the sum of the number of those subzones. Okay, so I want to sum. What do I want to do? Ooh, could I do a pick? No, no, that won't work. All right. So let NBR count be count awk of NBRs, comma, +1. Then I want to filter sum of filter subzn, where neighbor count equals min of neighbor count. And just take off the sum for a second. 626, 107, that's it. I was expecting more, but okay. So 6 is over here, only has 2, right? Yeah, because most things, even at the edges, most things have 326. 107, yeah, that has more, that has more. Okay, where's 107? Here, yeah, okay, fine. I buy it, I buy it. Put the sum back in. What are the coordinates of the terrain that is surrounded by the greatest number of terrains different from itself? Now this one I remember getting wrong because I think what this meant was the greatest number of unique terrains different from itself. So, how might we go about doing this? I think neighbor op might be the answer. So we're going to say neighbor op of tmap, the distance of 1, and just do array to text for now. So that gives me everything that borders on that. Then, I want to map that and tmap, and I want to figure out how many things are in this list that are not this, and how many unique values. So we will say, oh, and there are things that are surrounded entirely by themselves, so fine. So we'll wrap it all in an if error 0. Oh, sorry, first we need a lambda. A, B. Then we're going to say rows of unique, of filter, of text split, of A by a comma space, where that is not equal to B. I think that's it. So this says this has 0 neighbors different from itself, which makes sense. And here's something that has 2 neighbors different from itself at, where are we? 8, 8, 7. So, sorry, 8, 7, yes, here. So that has that and that, which are yes. Okay, I think that works. Then what is the question? The latitude, longitude. Okay, so I want to say let A be all that stuff. And then I want to say if A equals max of A, then row of tmap, sorry, bracket and row of tmap and comma space and column of tmap and bracket, otherwise NA, or actually we can just make this an ifs and then I don't need an otherwise NA. And then I want to call that ignoring errors. And there it is. Yeah, that's fine. Don't have any references that need to move. Nope, cool. All right. Considering the subzones given in questions 91 through 130, which terrain appears most frequently and how many times does it appear? Each terrain should be counted only once. Answer must follow the same format as level 6. Disregard the examples. Okay, so let zones be 91 through 130. So here, it's going to be unique of the stack of this with this times 1. Then what's the level 6 format? So no, it's the thing that appears most often. So it's going to be text join, text join with a comma space, take most of, choose, no, forcing myself to use pick, gotta get in the habit, pick from RCs by zones, row header is subzone, and then 2ref of that on tmap. Okay, so that's the 2ref, that's the most of, that's the take, and I want to take the first row, text join, dense forest 86, and boom, stop time, 29 minutes and 47.86 seconds. Just got it done in the half hour, which honestly I'm pretty happy with. This was not an easy case, but now I have 13 minutes to process the video, create a thumbnail, and get it posted for no reason other than my arbitrary choice that 11 a.m. is the time that I post videos. But anyway, I'm off. That's all I got for today. Thanks for watching. See you next time.